Alright, so I wanted to make this quick video about how to draw motion maps. So we have a couple of scenarios here, and we want to draw motion maps to visually represent how the car in this case is moving. A motion map is this idea that if something is moving, let's say someone is walking and it's completely dark. Completely dark, you can't see him, but there's a strobe light, and that strobe light is going off every 1 second. As they walk, you're just seeing flashes of where they are. And you can tell by how far apart the flashes are, how fast they're moving. So when the flashes are far apart, that means they're moving faster. If they're closer together, it means they're moving slower. So this guy seemed to be moving pretty constant, and then it looked like he sped up over here. So imagine with these motion maps that the flashes are occurring 1 each second. And rather than draw the object each time, we're going to be lazy and just draw a dot that represents the center of the object, like the center of the person. I could just draw dots for that. So here's my car. This is at time 0. So 1 second later, it's going to be, let's say, there, and it says it's moving at a constant speed. So I have to show the same spacing. That's 1 second, 2 seconds, 3 seconds of the same spacing. I'm going to put an arrow here just showing that that's the way we're headed. Then it speeds up for 2 seconds. So 2 more seconds I've got to show it going fast. So speeding up here. Finally it slows to a stop over 4 seconds. So I've got to go a little bit slower, 1 second, a little bit slower, 2 seconds, a little bit slower, 3 seconds, a little bit slower, 4 seconds. And you can also show a complete stop by kind of dropping it down. Technically that's like 4 for the slowing down and then 1 to stop, but that gets the idea across, and it doesn't have to be exact on this. So that is representing this first scenario. If I have the second scenario, which is a car now moving to the left, so I'm going to start over here, and this one has numbers, so 5 meters a second. I'm going to just make up a spacing and say, okay, that represents 5 meters. I don't actually have to draw this, but it helps it be a little bit more accurate in my mind. So that in this second we covered 5 meters, so that's 5 meters a second. So that's 1 second, here's 2, here's 3, there's 4. And then we slow down and stop in 3 seconds. So 1, 2, 3 to there. And now I'm waiting for 2 seconds. So 1 second passes, I haven't moved left to right. Another second passes, I haven't moved left to right. Now I go in reverse at 1 meter a second. And if that distance was 5, so then 1 meter would be about 1/5 of that. So this is 2.5, 1/5 is going to be maybe something like that. So now I'm going the other way, 1 second, 2 seconds, 3 seconds, and 4 seconds. And I'm going to put an arrow here to show that now that went that way. So you can kind of follow with the arrows, started here, and then stopped, and then went this way. Sometimes people like to do arrows, or sometimes called vectors, that the size of the vector represents how fast you're going at each point. So if you did that, and you don't have to, but if you did, this would be moving at the same speed. So I do a pretty big arrows for these gaps. And then here the arrows need to get smaller because you're moving slower. So this is like one more little thing that sometimes helps people. And then here we're moving even slower yet. So like I say, you don't have to do the red vectors, arrows, to represent the motion, but you can if it helps you make sense of it.